Welcome to the end of the notes for solving radical equations. And these are the extra problems at the end. And I have just kind of split these apart, and I want to work a few of them for you so that you can see how the harder ones are worked. The ones 1 through 4 are fairly easy, and I think you should be able to do those and check your answers because the key is on the bottom of this page or on the back side of this page. So let me work a couple of problems for you here. The first thing we always do is assess whether that radical with the variable is by itself on one side of the equation. And it is. So we are ready to square both sides. Now we're going to subtract 4 from both sides. We're going to get 12m is equal to 12. And m is equal to 1. Let's do our check. And this is 12 times 1 plus 4 is 16. And square root of 16 is 4, so this checks. And our solution set is 1. Okay, let's go to this next one. Now this is an interesting one. This is a type that you haven't seen before, where we have a radical x on one side by itself, it just has a coefficient, and a radical on the other side. And it's also by itself. So we want to leave those two on either side. And we're just going to square those. When we square this side, we square both the 3 and the root x, so we get 9x. And when we square this 3x plus 12 comes out from under the radical. So we're going to subtract 3x from both sides, and we're going to get 6x is equal to 12, and x is equal to 2. So we're going to do our check. And we're going to say 3 times root 2 and ask ourselves, is that equal to 3 times 2 plus 12? Interesting. 3 root 2 is equal to, this turns out to be 6 plus 12 is 18. Okay, if you factor that into its perfect square component and its regular component, then you get square root of 9, square root of 2, which turns out to be indeed 3 root 2. And so we can go back and put our solution is x is equal to 2. Okay, let's have a look at this one. We have the x on one side, the radical is by itself on this side, so we're ready to square both sides. And we have x squared is equal to 2x plus 3. Now we're going to move everything over to one side and set that equal to 0. So we're going to subtract 2x and 3 from both sides. And then this becomes an AC factor problem. And we've got a times c is negative 3 and b is negative 2. So 1 and negative 3 are our factors. Let's see, is that right? Did I not put, oh, I didn't put the plus 1. I'm going to fix that. I bet some of you caught that too. I can just hear it. Mrs. Morris, you left out the x. Minus 3x plus 1. So our two factors are x minus 3 and x plus 1. So our two candidates are x is equal to 3 or x is equal to negative 1. So now we're going to check. I wonder if you can already tell which one or whether both of them are going to be valid. So let's plug in x is equal to 3. So we have 3 is equal to 2 times 3 plus 3. 3 is equal to 6 plus 3 is 9. 3 is equal to 3, and we are good. So let's check negative 1. Negative 1 is equal to 2 times negative 1 plus 3. Negative 1 is equal to, this is negative 2 plus 3 is a positive 1. Negative 1 is equal to 1. Oops. No. So we write our solution set, which is x is equal to 3 and negative 1 is extraneous. And I bet on one of the previous examples I did not write which one was extraneous. Let's go back and have a look at that. Did we have? Nope. Nope, we were good. We only had one solution on each of these. Up above on 1 through 4 you will find some extraneous roots. Okay, let's have a look at this one. It's kind of ew, but first we check and see if this radical is isolated, and it is. So we're going to square both sides. So when we square this side, 22y plus 86, those are awfully big numbers, is equal to y plus 9. Please put those side by side and FOIL this out. Okay, y times y is y squared. We have a 9y plus a 9y, which is a positive 18y, and then we have a y squared is 81. So we need to collect everything over with the squared term. So we're going to subtract 2y, 22, that's a 22y, that should be a 22, and an 86 from both sides. And we get something that looks more human, which is a negative 4y and a negative 5. And this should be a squared term. So I'm just going to come up here, do my AC factoring. My b is a negative 4. A times c is a negative 5. So I have a 1 and a negative 5 as my two factors. And y plus 1 minus 5y plus 1, y minus 5, and y plus 1. So our two candidates for y are 5 or negative 1. So let's do our check. Square root of 22 times 5 plus 86, that seems like an awfully big number, is equal to 5 plus 9. So 22 times 5 is 110, and 5 plus 9 is 14. So 110 and 86 is square root of 196, that should be a 6. And square root of 196 is indeed 14. So that one checks. So let's check the other one, which is negative 1. Square root of 22 times negative 1 plus 86 is equal to negative 1 plus 9. I wonder if this is going to come out. Negative 22 plus 86 is equal to 8. 22 plus 86, I believe, is positive 64. And square root of 64, of course, is 8. So that checks. So our solution set for this problem is 5, negative 1. Okay, I'm going to skip down to problem 10 because this one has a wrinkle to it, and I want to make sure that you see what the wrinkle is. Okay, so we evaluate it first, and we discover that this is it's a number, but it doesn't, the x is not in the radical, and this x is not in the radical either. So we don't have to square because we don't have any variables under the radical. So what we're going to do instead is we're going to factor. And then we're going to divide by that number. And we're going to get 2 over 3 plus root 5. And now I know, so this is actually the answer, and since we didn't do any squaring, that is the answer. But I want to make you aware, I'm going to put a little star here. We usually don't leave a radical in the denominator. But in this case, I have not given you the tools to get this radical out of the denominator. So in this case, it's okay to leave it. Okay, let's just do one last problem. We're going to work number 9 as long as we're here. And the first thing that we have to do is determine whether we have one of our variables under a radical, which we do, and whether it is by itself, which it is not. So we're going to subtract 3x off of both sides. 5 root x is equal to 2 minus 3x. Now we have that radical by itself. We're going to square both sides. Okay, when we square something like this, the square acts on both the 5 and the root. 5 squared is 25, and the root comes out of the radical as x. And then we've got to put this one side by side and FOIL it out. Okay, 2 times 2 is 4. 2 times the negative 3x. Actually, we've got 2 of those. Positive 2 times negative 3x. Positive 2 times negative 3x. So that is a 12x. And then negative 3x times negative 3x is 9x squared. And I would encourage you, if you need to go back and review that, to do so. We're going to get it alone. So 0 is equal to 4 minus 37x plus 9x squared. And I'm not going to belabor the point because actually this is a very similar problem to one that we did above. You're going to get 2 solutions and you're going to check, and I'll bet you anything that one of those solutions is not possible. So thank you for tuning in. I hope this has helped.